Welcome pre-cal students to class today on Wednesday the 15th. Hope you guys are doing well. Hope you're ready to learn some math today. Let's go over a couple quick announcements. There will be a quiz on Saturday. I will email that out to you probably Saturday morning or so. And that quiz, I'm going to change the rules just a little bit. I really am going to hold your feet to the fire. I would make the quiz be due on Monday. I really would. But the problem with that is in case you have any questions, you don't have time to come see me. And so what I'm going to do, I did say Wednesday before. Don't forget, now listen, tests. When you come to my house on different Mondays, tests are due on Wednesday. That gives you 2 days. So quizzes are going to be due on Tuesday. And that means they're in my hand, questions asked, totally completed by Tuesday. Guys, again, not only are my requirements not unreasonable, they're looser than what a normal school would do. Okay, guys? I mean, every kid who goes to a school in the city of Chattanooga gets up every day, goes to school, and their homework's due the next day. You guys can kind of get behind on videos and do 2 in one day and skip a day and do 1 on the weekend and stuff like that. So nothing I'm doing is unreasonable. I gave a quiz to my geometry students today at Berean Academy, and they took the quiz and turned it in all in the same class period, which is normally what you do. So your quizzes are due on Tuesday. So this Saturday you'll have a quiz. It has to be in my hand, totally done, completed, all your questions asked by Tuesday. Stay on top of your integrity sheets. When you come into my house on the day for a test, whatever you have done is what counts. You can't go back and do anymore. So keep that in mind. Let's work hard. Are you ready, guys? Here we go. Get your notebooks out, pens, pencils, calculators, books, and let's get started, okay? Here we go. We are going to be looking at 2 topics today. Now, do understand that one is easy and one is difficult, okay? Let's quickly knock out the easy topic here in a couple minutes and then spend most of our time on the more difficult topic. And it will be difficult, okay? Write this in your notes. Now remember, before I get started, I go fast on purpose because you can't speed up a video, but you can always slow it down by pausing it, okay? So I know when I say stuff, you're probably not done writing it down, and that's okay. Just pause the video. Your heading today is called Summation Notation or Sigma Notation. Books use both of these titles, so either one is acceptable. The date today is the 15th, and we're still on lesson 10.1, which is fine. It's a big lesson and a lot to learn. I'd like you to write this in your notes, please. This is an example of summation notation or sigma notation. This is a math problem. Please copy this down. This is the Greek symbol or letter sigma. Now, I've called them for years summation notations. That's probably the phrase I'm going to use. You're welcome to use either one. But please copy this in your notes. Little Greek symbol here, k equals 1 with a 5 up here, k cubed. Okay? Please write that down. Now, I do want you to look intelligent when you go to college. Here's how you would say this. You would say the sum, so you know now we're going to add a bunch of stuff together. The sum, as k goes from 1 to 5, of k cubed. Now, I say it a little differently. I say the sum of k cubed as 1 goes to 5. Or excuse me, as k goes from 1 to 5. Either way is acceptable. And I forgot to put quotes here, didn't I? There we go. Whatever. I just want you to look intelligent so you don't walk into class one day and say, yeah, that thing over there. It's the sum as k goes from 1 to 5 of k cubed. Or you could say the sum of k cubed as k goes from 1 to 5. Now, k is called your summation of notation. K is called your summation of notation. Now, it's not always k. You could have an I here and an I here. You could have an X here and you could have an X here. So it doesn't have to be K. Understand that, okay? That's not the issue. It's just whatever this letter is right here, right there, that letter is called your summation of notation. You need to know that, okay? And now with that in mind, let me go ahead and quickly teach you how to solve this problem. This is the easy stuff. We're going to go really fast. They're not difficult. They're very simple. A little long sometimes, but not hard to do. So we're going to solve this problem, then look at one more, and then get into the difficult stuff. So here we go. Notice the bottom number is 1. That's called your least value. You don't have to know it, but it's called your least value. 1 is your least value. 5 is your greatest value. Now what that means is you're going to put 1 in for k, then you're going to put 2 in for k, then 3 in, then 4 in, and then 5. So you're starting with 1 and you're ending with 5. And then you're going to add all of those up. Let me show you, okay? Our summation of notation is k, and we're using k cubed. See that right here? K cubed. So my first number is 1, so I'm going to put a 1 in for k. There. I put a 1 in for k. Then I put a plus sign. Then I put a 2 in for k. Then I put a plus sign. Now you see why it's called summation. Sum means add. We're adding. Then you put a 3 in for k. Then you put a 4 in for k. And then you put a 5 in for k. Now, I hope you know by now I'm not a lazy teacher. I'm here for you guys. I help you a lot. I didn't work this out ahead of time, but I mean, there are some things we can skip in the video. I'll try to quickly do it in my head, but if I get it wrong, understand your calculator would do this for you. But the main thing is, do you see what I've done here? Your expression is k cubed, and so everywhere there's a k, I put a 1. So 1 cubed is 1. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. If I got any of those wrong, remember I'm doing it in my head. And then if you add these together real quick, I'm getting 9, I'm getting 189, I don't know, plus 27, plus 8, plus 1, 24, 25, carry your 2. I'm getting 225. If I'm wrong, the main thing is you know how to do this, okay? So I'm not being rushed and I'm not being impatient. It's just that let's focus most of the video time on the more difficult math, not the easier stuff. So this is pretty easy. Okay, let's look at one more example. You can pause the video and work ahead, or you can watch me work this out. It's up to you. Notice our summation of notation is I. So everywhere there's an I, we're going to put a number in. We're going to start with 0 and work up to 6. So here's our expression. -1 to the I power times 5 to the I power. So let's put a 0 in. So I have -1 to the 0 power, 5 to the 0 power. Do you see that? Here's an I put a 0. Here's an I put a 0. Why 0? Because that's my number right down here. That's my least value. Now, I then put a plus sign. Now I'm going to put a 1 in for I. So -1 to the 1, 5 to the 1. And then put a plus sign, and then put a 2 in. So -1 to the second power, 5 to the second power. Then a plus sign. Now we're going to put a 3 in. And I told you these could be a little long, but they're not hard. And if you learn how to use your calculator correctly, it should do most of this for you, okay? And I think I'm going to change the problem, so please feel free to do that. I'm not being lazy. I'm just trying to save time. Let's go ahead and make this 6 right here. Go ahead and change that to a 5. We'll just stop right there. It really doesn't matter. Let me check my work and make sure I've done this correctly. I'm known for my little mistakes. Okay, so anything to the 0 power is 1. 5 to the 0 power is 1, so 1 times 1 plus. -1 to the 1 power is -1. 5 to the 1 power is 5 plus. -1 to the second power is a +1. -1 times -1 is 1. And 5 squared is 25. -1 to the third power would be -1, because -1 times -1 times -1 is -1. And 5 to the third power is 125. And then plus. And then -1 to the fourth power would be 1. And then 5 to the fourth power would be 25 to 625. And then -1 to the fifth power would be -1. And then 5 to the fifth power would be 625 times 5, 25 carry 2, 2 carry 1, 3125. So 5 to the fifth power would be 3,125. Okay? And now let's simplify each term. 1 times 1 is 1, plus -1 times 5 is, that should be a -5. Let me fix that real quick. 1 times 25 is 25. Negative 1 times 125 would be negative 125, plus 1 times 625 is 625, and then negative times a positive is negative 3,125. Now, again, you're big pre-cal students. I'm not going to take time and add that up for you. I would encourage you to quickly take your calculators and finish this so you have an answer. But that is all that you're doing in your summation of notation problems, okay? So they're not that hard. You do need to know how to do this. We will be using formulas later using summation notation or sigma notation. So it's very, very, very important that you know how to do this, okay? But having said that, now let's focus most of our attention on the more difficult math. Go ahead and copy this in your notes. The topic now we're going to look at that's more difficult is called writing nth terms. Writing nth terms. They also call this general terms. So we can call it general terms or nth terms. Be familiar with both of those. And the date today, of course, is still the 15th, lesson 10.1. All right, let's continue on. You should remember how we learned yesterday that I can give you an nth term, like this one right here, and I can ask you to find any term, like term number 5. Okay, you should remember that. Today we are going backwards, and this is difficult. I'm going to give you a sequence of numbers, and I want you to find the nth term. Now this video today is not going to be long. You're going to be surprised. These problems are not difficult because they're long. They're difficult because they're just hard to figure out, and there's no steps. It's looking at a situation and then figuring it out, and that's what's so difficult about these. So let's go ahead and jump into our first problem here, okay? All right, write this in your notes. This is a sequence. I'm giving you a sequence, and I want you to write an nth term or a general term like this one up here, something like that, okay? Now, first of all, I want to encourage you to do a couple things. I don't have steps for you, but I can give you some suggestions. Just like when we were proving trig identities, I gave you some suggestions. All right, first of all, it always helps to put the number of the term above the term. So this is my first term, this is my second term, this is my third term, and this is my fourth term. Okay, there we go. That helps because remember something, students. Please listen to me. Watch this. If I asked you to find the fifth term using this nth term right here, what would you put in for n right here? We learned this yesterday. Would you not say 2 times 5 plus 3 would give you 13? So now you know the fifth term is 13. Why is that so important, Mr. Earhart? It's important because I wanted to show you that whatever term you're trying to find, that's the number you put in for n. And that's why I'm encouraging you to put these term numbers above each term, because that's actually what you're going to substitute in. Now, if you'll look at the numbers here, you've got to try to find a pattern. And you're like, Mr. Earhart, this is hard. Yes, it is hard, but you're going to have to try to find a pattern. Now, the first thing I notice is I have a 2 here and a 2 here, and a 3 here and a 3 here. Now I'm saying to myself, hold it. See if this makes sense, guys. I have square root of 2 here. I have square root of 3 here, right? Well, this is a 2. Could I not put square root of 4? Is not square root of 4 the same thing as 2? Sure it is. So instead of putting 2, I'm going to put square root of 4. And hold it, I just had a thought. See this 1 right here? Instead of putting 1, I could put what? Square root of 1. Because the square root of 1 is what? 1. The square root of 2 is what? Square root of 2. The square root of 3 is what? Square root of 3. And the square root of 4 is what? 2. Well, Mr. Earhart, why did you do that? Because I'm looking for a pattern. I've got to find the pattern. That's an R right there in case you're wondering. Doesn't look like it, but it is. Guys, how in the world can you write an nth term or a general term until you have first found the pattern. I think I see the pattern now. For term number 1, it's square root of 1. For term number 2, it's square root of 2. For term number 3, it's square root of 3. For term number 4, it's square root of 4. I'm seeing the pattern. So my nth term would be this. Are you ready? Watch. My nth term would be square root of n. See if that makes sense. Watch. See if this makes sense. Erase this. Erase this. Let's go back to the original problem, okay? Let's erase all these little term numbers here. All right, now watch this carefully. To find the first term, put a 1 in. If I put a 1 in for n, what do I get out? Square root of 1, which is 1. If I put a 2 in for n, what do I get out? Square root of 2, which is the second term. If I put a 3 in for n, what do I get out? Square root of 3, which is the third term. If I put a 4 in for n, what do I get out? Square root of 4, which is 2, which is my fourth term. So every time I put a number in, I got out the correct term. So you just found the nth term for these right here. You know what dreaded word you need to do well on these? Yeah, you know what the word is, practice, which means homework, okay? We're going to look at 3 more of these, and then I want to recommend something to you on your homework when we get there, okay? All right, let's try another problem. Okay, let's write the nth term for this sequence. Now I want to recommend, first of all, that we write the term numbers up top. Very good. Now I'm going to look for a pattern. Well, I'm not the smartest person in the world, but I'm kind of noticing here that we're multiplying by 2. 2 times 2, 4 times 2, 8 times. So I'm thinking, hold it. I could really rewrite this thing as 2 to the what power? 2 to the what power? Because I'm multiplying by 2 every time. Look at that. That's perfect. And I noticed something else. Matthew, Caleb, I noticed that for the first term right here, I have a 1 right here. And for the second term, I have a 2 right here. And for the third term, I have a 3 right here. And for the fourth term, I have a 4 right here. So I think I know what my nth term is. I think I'm going to have 2 to the what power? N power. That makes sense, because let's go ahead and finish this. You'd want to write a subscript n equals. That works, guys. Now come on, think about it. If I put, here's my nth term. If you put a 1 in right here for n, you get 2 to the 1, which is your first term. If you put a 2 right here for n, you get out a 4, which is your second term. If you put a 3 right here for n, you get out 8, which is your third term. If you put a 4 right here, you get out 16, which is your fourth term. So this nth term does work. Now the first 2, I hope I'm not scaring you by saying this, the first 2 are pretty easy. The next 2 are a little more challenging, so I really need you to pay attention and take some good notes. Guys, I'm not the best teacher in the world, but I'm telling you now, there's no teacher that's going to teach this by step 1, step 2, step 3. Okay? You've got to look. I mean, I can give you ideas. I first of all encourage you to write the term numbers up top, and then to try to find a pattern, and then be creative from there. And it's going to take practice. Okay? But it's very, very important you know how to do this. All right, let's continue on. Okay, let's start with this top sequence here. We'll get to this one down here later. Okay? All right, here we go. Well, I've taught you it's kind of helpful to put the term up here, so I'm going to call that term number 1, term number 2, term number 3, term number 4, term number 5. And then I've told you to look for a pattern. Well, it looks like we're multiplying by a -3 over and over, like 1 times -3, or -1 times -3 is +3, 3 times -3 is -9, -9 times -3 is 27. So we're multiplying by a -3. And see how the signs go back and forth, negative, positive, negative, positive, negative. There is something I can teach you about that when it comes to writing an nth term. that helps a lot with that, so we'll get to that in just a little bit. But first of all, let's try to find a pattern. It looks like we have 3 to a certain power. Like, see this? 3 to the 1 power. This would be 3 to the second power. No, Mr. Earhart, what about the negative sign? Don't worry about the negative sign. We'll talk about that later. This is 3 to the third power. This is 3 to the fourth power. What about this over here, Mr. Earhart? Well, it's 3 to the what power? Come on, guys, you should know. 0. Anything to the 0 power is 1. Again, don't worry about the negative signs. We'll deal with that later. But do you see the pattern? 3 to the 0, 3 to the 1, 3 squared, 3. Now, look, please look, guys. Let's go back a page. Over here, do you see how the powers matched the term? Term number 1 had a power of 1. Term number 2 had a power of 2. Term number 3 had a power of 3. Do you see that? This is a little different. Term number 1 has a power of 0. Term number 2 has a power of 1. Term number 3 has a power of 2. Term number 4 has a power of 3. Term number 5 has a power of 4. So I'm going to come over here and I'm going to write 3 to the n power. But that doesn't work. Can I show you why? If you put a 1 in for n, you don't get out the first term. So somehow I want this n to be a 0 when I put a 1 in for it. In other words, do you see how 0 is 1 less, 1 is 1 less, 2 is 1 less than 3, 3 is 1 less than 4, 4 is 1 less than 5. So how about, instead of putting 3 to the n, how about if I put 3 to the n minus 1? Let's see if that works. Put a 1 in for n, put a 1 in right here. What's 1 minus 1? 0. So I get 3 to the 0 power, which is 1. Now let's put a 2 in for n. 2 minus 1 is 1. 3 to the 1 power, that's the second term, it works. Let's put a 3 in. And let's see if we get out the third term. 3 minus 1 is 2, so we have 3 to the second power, and that's my third term. We're good. This works, guys. This totally works. Why am I using n minus 1 instead of n? Because all of your powers down here, do you see how they're 1 less than the terms up here? They're 1 less. And that's the reason why. Now, Mr. Earhart, let's talk about the negative sign. Okay, sure. I'm glad you brought that up. Let's talk about the negative sign. This is something you can kind of memorize. It will help you 99.9% of the time. Whenever you have an alternating sign like this, if you get the number part figured out like we did here, but the signs are not accurate, you can come out here and you can put this. This is really cool. You can memorize this. -1 to the n power times this. Now, what that does is, well, let me show you what it does. This is so cool. Watch this. Anytime you need alternating signs, starting with a negative sign, like this, if the negative sign's first in the first term, you can put -1 to the n out front, and that will help the signs go back and forth. Watch, let me show you. Let's put a 1 in for n and watch what happens. -1 to the 1 power times 3 to the 1 minus 1. Now, 3 to the 1 minus 1, that's a 0. 3 to the 0 is 1. And -1 to the 1 power is -1. And -1 times 1 is -1. Booyah, it worked. Now, watch this. Now let's put it, Mr. Earhart, now you're going to get a negative out for this one right here. No, I'm not. Put a 2 in. Put a 2 in and watch what happens. It's so cool. So we have -1 to the second power times 3 to the 2 minus 1. Now, watch this. 2 minus 1 is 1. 3 to the 1 power is 3. And now because this is an even number, -1 to the second power, -1 times -1 is a positive 1, and 1 times 3 is 3. And I get out a 3. Let me give you one more example and I'll stop. Let's put a 3 in, our next term. We should get out -9. So -1 to the third power times 3 to the 3 minus 1. Now, 3 minus 1 is 2, so we have 3 to the second power, which is 9, and then -1 to the third power, because this is an odd exponent, negative times negative times negative is negative, and 1 times 1 times 1 is 1, so -1 to the third power is -1, and -1 times 9 is -9. Boom, it works. So that's something there. That is a little shortcut, a little memorization tool. Anytime you have alternating signs and the first term is negative, most of the time you're going to put -1 to the n power. Okay? Let's take a look at one more problem. And then we're done. That's it. I told you it wouldn't be a long video, but these are going to be really difficult in your homework. You're going to have to really, really learn to work on these, okay? So here we go. All right, now the second problem here. Please go ahead and copy this in your notes and listen to me. Pause the video if you need to and copy this down. Now, if we didn't have this -10 right here, I take that back. I was making a mistake. I apologize. If you'll look at what we're doing here, we're adding 2 over and over and over. Okay? And that is true. We are adding 2 over and over here. Of course, I know the signs are a little confusing. We'll worry about the signs later. Remember, we can take care of the signs by putting -1 to the n power. So the first thing I'm going to do is I'm going to write the terms above each one. Now, instead of writing like, okay, we got +2, +2, +2, +2, hold on a second. Forget the negative signs. Let's just work on the numbers. I'm seeing a different type of pattern. I'm saying this. Now watch, see if this makes sense. I'm seeing here I can put 2 times 1 for this term. And here I can put 2 times 2. And for 6 I can put 2 times 3. And for 8 I can put what? 2 times 4. And for 10 I could put what? 2 times 5. Do you see how I look for patterns, whether it be with exponents or multiplying or adding or something? Mr. Earhart, why is this pattern here so important? Are you kidding? Look at this. What term is this? The first term? And what number do I have here? A 1. This is my second term, and what do I have here? A 2. This is my third term, and what do I have here? A 3. This is my fourth term, and what do I have here? A 4. This is my fifth term, and what do I have here? A 5. That's amazingly helpful. And then notice this. Every term has a what in front of it? A 2, a 2, a 2, a 2, a 2, all the way across. So I'm saying, hold it, my nth term is simply 2. Up here, by the way, I should have finished this and I apologize. Always learn to write your term like this. Always put a subscript n equals. But back down to here, look, I've got it. My nth term is simply 2n. I mean, think about it, guys. 2 times 1, 2 times 2, 2. What does not change? In each term, what doesn't change? A 2, a 2, a 2, a 2, and a 2. So I put a 2 right here because everyone's going to have a 2. And then what does change? Well, this number here, notice each number matches the term number. So I'm just going to put it in. So if I put a 1 in for n, 2 times 1 is 2. If I put a 2 in for n, 2 times 2 is 4, which is my second term. If I put a 3 in for n, 2 times 3 is 8, or 2 times 3 is 6, which is my third term. Okay? Now let's talk about the negative. Remember, it goes negative, positive, negative, positive, negative. My first term is negative. So I've taught you, you can put this expression right here in front of it. So -1 to the nth power times 2n. You did it. That's it. So this part here took care of the numbers going 2, 4, 6, 8, 10. This part here took care of the signs going negative, positive, negative, positive. I'll show you real quick. Put a 1 in for n, and you would have -1 to the 1 power times 2 to the 1 power. Well, 2 times 1 is 2. -1 to the 1 power is -1. 2 times -1 is -2. Works perfectly. Now, let's real quick do one more, and I'll stop. Let's put a 2 in for n. All right, let's put a 4 in. Let's put a 4 in for n. So -1 to the 4th power times 2 to the 2 times 4. 2 times 4 is 8. -1 to the 4th power is a +1. 1 times 8 is 8. And there's the fourth term, 8. So it does work. Now, here's my suggestion to you on your homework. My suggestion to you is you might want to watch the video while you do your homework. That's up to you, but you might want to watch the video as you do your homework and kind of get some help with these because they are difficult, and you might want to kind of have your hand held as you do these to get your confidence up. These are the easy ones here. They can be kind of long. I only gave you, let's see, 33, 37, 5 of these, and it's every other odd. So you do 33, 37, 41, 45, and 49, every other odd. These are the odds right here. Okay, I'm having a little problem downloading the homework video. For some reason, the camera I use which takes pictures of the problems and then puts them in the computer is not working, and so be a little patient with that. It'll be up just a little later than usual, but other than that, it should be good to go. I'm working on that right now. So that's it. Have a good day. Call or email if you have any questions.